Hi everyone, welcome back to Learn Math with Jessie. Today we're going to cover how to solve systems of equations. The first method I'm going to show you is an elimination method. We use this when the same term appears in both equations and can cancel right away or after a quick multiplication. So let's look at this example. Notice that they both have this x squared in it. Also notice that you can multiply the second equation by 2 to obtain this same 2x squared term. So that's what we do. And elimination consists of subtracting one equation from the other. So when we do this, notice that we don't get any x squared term. It becomes 0. And then we do 3y squared minus 2y squared, so it gives us 5y squared, 38 minus 4, which gives us 34. We divide by 5, and then we take the square root on both sides, which gives us plus or minus 34 over 5. I just want to take a minute to appreciate why we use this plus or minus term. The reason being is when we multiply two of these negative square roots, we get a positive. So it gives us the same thing as if we just had two of these positive square roots. That's why we have to include both the negative and the positive value. Alright, now that we've found our y value, we must find the corresponding x values. So we use the simplest equation of the two, which is the second, and we isolate x. So this is 2 plus y squared. And recall that y squared is just 34 over 5. So we can directly plug this in. And then we get x squared is equal to, well, we have to first put the 2 on the same base. So we do 2 times 5 over 5 to get 10 over 5. And then we add this to the existing 34 over 5 to obtain 44 over 5. Now this is the same process as before. We take the square root on either side. So we get plus or minus 44 over 5. So now we've essentially found the solutions, right? So now we just have to establish what these x, y coordinates are. So we have plus or minus for both, meaning we're going to have 4 distinct solutions. So the first one, x and y are both positive. Second one, x is negative, y is positive. Third one, x is positive, y is negative. And the last one, x is negative and y is also negative. Now I just want to take a moment to show you what this actually looks like on a graph. So we have that first equation there as a circle and the second equation there represented in blue, and we clearly see that there are these 4 points of intersection. Next, moving on to this example, again we use elimination because we have the same term that appears in both. So we do x squared minus x squared, we get 0x squared. Notice that we only have this y squared term in the first equation. So it's like doing y squared minus 0, so it's y squared that gets carried down. And then this first equation doesn't have a y. So it's like we're doing 0 minus 2y, which gives positive 2y. And then 16 minus 8 is 8. So then we bring this 8 to the other side, and notice that here we have a quadratic equation. So here we can solve using the sum product method, which I've gone over in previous videos, so you can find that on my channel. So essentially here we're just performing the factorization. So we obtain y minus 2 times y plus 4, and then essentially this gives us y is equal to 2 and y is equal to negative 4 as values. So again, we're going to have to plug these values into the simplest of the two equations, which is going to be the second, to obtain our corresponding x values. So taking the second equation and isolating x squared, we get 2y plus 8, and plugging in this negative 4, we get negative 8 plus 8, which gives us 0. So that's going to be, x squared is equal to 0, so x is therefore 0. Next, we again take the second equation, and now we're using our y is equal to 2 value. So we obtain 2 times 2 plus 8, which gives 12. So we get x squared is equal to 12. So now again, we take the square root on both sides, and we get plus or minus 12. So we have this 0, negative 4 pair, and now we have this positive root 12 and 2 pair, as well as this negative root 12 and 2 pair. All right, so again, I'm just showing what this looks like on the graph. We have a circle as the first equation, a parabola as the second equation, and then we have these 3 points of intersection. So I just want to point out that the value on the left is indeed the root 12, and the value on the left is negative root 12. Now moving on to the second method, substitution. We use this when the equations are not aligned for cancellation and when one variable is isolated or almost isolated. So if we look at the second equation, that's the case. We can easily isolate x or y. So I chose to isolate x, so it becomes 7 minus y. So then we plug that into the first equation where that x is, so it becomes 7 minus y, all of that squared. So then when we expand that and we move the 25 to the other side, we get 49 minus 7y plus y squared minus 25 equals 0. Now we group like terms and we get 2y squared minus 14y plus 24 equals 0. Then we divide by 2 and we obtain this equation. Now we can do sum product on this. So this part is slightly sped up because once again, you can check out the video on my channel to learn how to do this. But we essentially get y minus 4 times y minus 3, and that's equal to 0. So we can therefore solve directly for y. We get y is equal to 4, y is equal to 3. And now to find our x values, we simply plug these y values back into that simple x equation. So for y equals 4, we get x equals 3, and for y equals 3, we get x is equal to 4. So those become our two coordinates, or our two answers for this problem. Now again, I'm showing you what this looks like on a graph. Here it's a bit simpler, right? Because we have this circle as a first equation, but the second equation is a linear equation. It's a line. So those are the 2 points that intersect with the circle. Okay, this last method is similar to regular substitution, except once we've substituted, we don't end up with a simple quadratic equation, and we have to perform a second substitution. So again, let's go like we've always done for substitution. So we take the simplest equation, we isolate for one of the variables. I decided to change things around, and here I'm isolating for x. So it's equal to 4 over y. And then we plug that into the initial equation, or to the first equation. So we replace that x by 4 over y. Make sure to put that in the bracket so that that square applies to both the 4 and the y. So then we get 16 over y squared. We multiply that 2 to get 32 over y squared plus y squared is equal to 18. Now we want to get rid of the y squared in the denominator. So we multiply by y squared, but if we multiply in one place, we have to multiply everywhere else. So then we end up with 32 plus y to the 4 is equal to 18y squared. Now I'm bringing everything to the same side. And again, notice like what I said at the beginning, we don't have a simple quadratic. We can't use sum product. We can't use the quadratic equation. So we take this idea of substituting y squared or by u. So y to the 4 becomes u squared and y squared becomes u. So we rewrite our equation this way. Notice we have a simple quadratic equation. So then here I go ahead and just show the result factored. Again, this is just basic sum product. And then at this point, we can plug the y squared back in to our equation. And then y squared minus 16 is a difference of squares. Sorry, so it's y minus 4 times y plus 4. We can't do anything with that y squared minus 2. So we obtain y is equal to 4, y is equal to negative 4, and y is equal to plus or minus square root of 2. Now again, this part is pretty simple. We have all our results for y, so we need to determine the corresponding x's. So the first one is 1, 4 for our final coordinate because the x value is 1. Second one has an x value of negative 1. So negative 1, negative 4. Then we have 4 over square root 2. So that becomes simply 4 square root 2, comma, square root 2, and then our last one is with our negative square root 2. So then we obtain negative 4 square root 2, comma, negative square root 2. All right, now I'm just showing you the graph again. So in red, we have this ellipse, and then the xy equals 4 is represented in blue, and we clearly see these 4 points of intersection. Thank you so much for tuning into this video and for learning how to solve systems of equations. See you in the next one.